All right, now we can start. Hopefully you still press the record. Plan B is always a good thing. Morning, folks. My name is Jeff Autor. I'm a distinguished technologist with Hewlett-Packard Enterprise. I also co-chair the Scalable Platforms Management Forum, which is the organization working group within the DMTF that owns the Redfish specification. So, and we're gonna have lovely challenges with these, I guess. All right, so I'm speaking today about not about Redfish the spec, which is great because I've done that a number of times here already, so don't want to do that again. So talking today about the Redfish Interoperability Profile. And I know it's been talked about several times already as far as, that this is something that OCP is engaging with DMTF on. So we're working together within the hardware management group here to get these things defined. So first is what is a profile or an interoperability profile? At first, apologize for the overloaded term. There's lots of things called profiles. We tried desperately to find another thing to call it, and everything else we came up with was worse. So we stuck with profile. So there's an old joke about how many different difficult problems there are in computer science. There's only two: naming things, cache coherency, and off by one errors. So, one of the things that we did when we built the Redfish specification was we separated the protocol from the data model first. So that meant that the protocol could be stabilized, but the data model could grow over time and evolve and extend. And so they're versioned independently, and furthermore, each of the individual resource schemas were also released separately, and they had their own version number. So I think it is, for instance, our computer system, which is the operational server component, or view of that. I think it's up to version 1.5 now. I think our chassis object is at like 1.6, but firmware updates at 1.1. They all have their own versions and so forth. So. This has caused, that was a good design point because it allowed all these things to evolve on their own without causing everyone to go revise things that didn't need any changes. But it has caused some confusion from the, what version of Redfish do you support, and those kinds of things. Those kinds of questions are not really as meaningful as they would have been in past specifications where everything was very rigidly tied together to a version. So that's kind of the first thing. The second thing is that each of the schemas defines, as Hemel said, it describes a resource or a particular subsystem. So there's a NIC schema, there's a disk schema, there's a chassis schema, and et cetera, et cetera. There's, I think we've up to like 75 different resource definitions now. But those schemas define what is possible, what can be implemented for that particular device or that particular resource. It does not say what must be implemented. In fact, in Redfish, there are very few things that have to be implemented, that are required. And that's really for a couple reasons. Number one is we wanted to be inclusive. If your device doesn't have a blinky light, saying that you had to have a blinky light, well, that would make you go either implement one, or worse, what we see in a lot of other standards is, well, I just kind of go fake it out and provide fake data to meet the standard. Like, okay, that's great. Now somebody sits there and tries to push the virtual button, and it doesn't do anything, and we all wrote a bunch of code that doesn't do anything, and it doesn't provide any value. So, we wanted to make sure that we had everything covered, but we didn't want to mandate a lot of stuff that, if it wasn't appropriate for your product, you didn't have to go implement it. But if you had an implementation, we wanted a place for you to put it. So this then, along with the versioning, then also creates a new problem is what features of Redfish do you support? What does your product actually implement? So we have a lot of folks that ask the questions, well, what should I implement? And, and the first answer is, whatever makes sense. Do what do your customers need? What do you want? What features does your product have? Implement that. If you don't have the functionality, don't implement that. That was a very confusing answer for some folks. Like, but I need a list. But really the folks that this really does affect are are both customers trying to buy things or trying to compare one implementation to another, say, do you have a very rich implementation or do you have a very, shallow implementation? And so to basically say that, yes, I support Redfish, is a kind of a nice nod. We like that from today, but it doesn't really tell you how much, information you can get through the interface. And secondly, if you're a software application, trying to do, say, manage an array controller, well, there's going to be, a list of probably 50 properties that you really need to have access to be able to do the configuration and do a good job of it. And so you need to make sure that that the devices that you're trying to monitor, actually, have all the data you need, or that what you can rely on. And obviously, if you have more data than what you need, well, that's great. You may have some stuff that you don't necessarily have to have, but it would be nice to have. That would be guys too, but again, it doesn't cause your software to fail. So for all those kind of reasons, we came up with the idea of a profile. And what a profile is just, is in human terms, it's just a checklist. So we take all the properties that are available in Redfish, in all the different schemas, and just kind of put them all down on a big list, and basically put check marks next to them. Like, do you have to have a serial number? Do you have to have a part number? Yes. Do you have to have the blinky light? Kind of go on down the list. And that summation of that list is the profile. So if you have everything that's in that checklist, you meet the profile. So that in a nutshell is kind of what a profile is. Now, the goal here was to make sure that we didn't want everyone to go create their own spreadsheets. So because if I get a spreadsheet from you and you and you and you, they probably have 95% in common, and you'll each have three little things that you really care about and nobody else did. And so basically it says, I still don't have a common ground. So we thought that it would be best if we had organizational level definitions done for profiles, and we could publish those, provide a tool suite that could test against those, and basically make this kind of a whole ecosystem, so that we could all kind of nod our heads and say, yeah, this is a good set of functionality for a particular class of product. So that's what that common ground really is the goal, and to make sure that both software developers and also end users saying, I want a good managed platform, and this is what I can, if it has if it meets a specific set of Redfish profiles, then it meets those needs. So we expect that there'll be a number of profiles. I don't want to see this blow up into 100. How many different server profiles do we need? Maybe 2 or 3. They may evolve over time. I don't want to see them. I don't want to see the profile of the month club. I don't want to have a list of logos and a laundry list of all the things I support on the back of folks that remember kind of the SNMP days, and how many MIBs I supported. Like, oh, here's 80. Oh no, I have 120 MIBs. Like, come on, folks. You'll never find the ones that you actually care about. So we try to want to keep these sort of simple. Don't want to make them horribly complicated, and also don't want to make them so prescriptive that that you get into areas where you are starting to stifle ways of implementing certain things. For example, you will see this when John gets into his part of the talk here. We really don't want to require you to implement things in hardware in a particular way. We want you to expose the properties of the hardware that's there. So I don't want to require a fan in a server, because you may have a liquid-cooled solution. You may have something that was fanless. And so, just because you came up with a better engineering solution, I don't want you to fail the Redfish profile because you don't have a fan, because that'll drive really bad behavior. You either put a fake fan. I'll make my liquid cooling thing kind of act like a fan. So this is all the behavior we're trying to avoid. So anyway, let me get into the rest of these, because I wanted to spend most of the time on the first 2 slides, because if I spend too much time on how a profile document works, you'll all fall asleep. Because I do, and I wrote it. So, like I said, so the usage of a profile, kind of what we see is the scope of what a definition would be. And so think of it as a kind of a class of product. I've used the example of just, what's a decent front-end web server? What's, hey, this is a pizza box server. What kind of manageability functionality should be required for that type of product? It may be something like, hey, this is more of an enterprise class database server, so there's probably a richer set of management functionality that needs to be there. This may be a storage device, and so it'll have a different set of things. In the way that we're working with the OCP profiles, there'll still be kind of some base level functionality that you would expect to have of any well-managed device. but the storage devices will have different functionality than a server device, as a for instance. So again, it's that meant to be that baseline of support. You know, you can always have more functionality than what the profile requires, and that's one of the important parts of the profile is you cannot say, you can't disallow something. You can always have more than what the profile requires of you, but it's not trying to stamp down to say you can't have anything more than this minimum. It is a baseline. So and as I said, this is effectively like a like a spreadsheet or a checklist, but I don't want to get 100 different one of these where they're 95% in common, but we have to sit here every day with everybody's RFQs and looking through them and finding out which of the 100 properties they they wanted differently. So trying to say what, let's get ahead of that curve and say if the different working groups and standards groups can define, hey, here's a good minimal set, and we can all kind of agree on that, then I think we can help a lot of folks just say, well, I'm just going to point to that one and say make that my minimum. So what takes up a profile? So there's an ecosystem of specs and tools that help you to both define, publish and validate the whole profile. So first is the profile itself. That like I said, it's not a spreadsheet. It is a machine readable file because we wanted to be able to create tools that would allow for validation of the actual profile against an implementation. But I also didn't want to make it horribly encoded that we had to have computer science grads having to go code the thing out and punch the things out in the cards. That was a joke for Hemel. So we did a JSON document and made the format very English centric, whole words spelled out. This is not something that gets transported on the network, so it is kind of verbose in its property names, but tried to make this such that that anyone that can, as long as you can figure out how many braces and commas and quotes to put in, and if your cut and paste skills are decent, you should be able to create a profile for yourself, or certainly review one that's been written by someone else. So the format of that JSON document is specified in a DMTF spec, which is the specification is number 272. There's a link there on the slide. And by the way, these slides are available on the DMTFs on the redfish.dmtf.org on the developer hub as well. That JSON document is backed by a schema, so there's a schema file that defines that, so you can apply the schema to a JSON a JSON validator, or excuse me, a JSON schema validator, and see that your profile document is is valid and meets the definitions. Then using that profile doc, you can take an implementation and use an open source tool published by the DMTF called the Profile Interop Validator. The Redfish Interop Validator, and that's on the DMTF's GitHub repo. That will take and ingest the profile document and then point it at a Redfish server service and let the tool run, and it will produce a report that says effectively yes, it met the profile or not, and if not, here are the particular issues. So that's a variant of our service validator, which is what we use for checking conformance testing, for checking conformance of Redfish implementations in general. So it will flag a lot of the same errors. And lastly, if you're actually creating your own profile, we also have, and this is a work in progress, and it's getting close to done now, but we have a documentation generator that will take your profile document, and it will take all of the text from the Redfish schemas, and then combine that together to produce really kind of an end user document that explains, like, here's all the stuff that's in my profile. And so it produces that in nice tables and organizes by schema. So it's a way for folks that are building a profile to look and to review it and share with other folks, especially anyone who's not at all interested in the how a profile document works and all the other inner workings. So pause there for a question, and then I'll get into the actual format of the document, which, like I said, I don't want to bore you guys to tears. Any questions about the? Yes.
So you mentioned the fan and the liquid cool. So if one profile requires a fan,
Yeah, so the question was if, if a fan was required, that, if you were liquid cooled, then you wouldn't meet the profile. That's correct. And so that's why when you see some of our examples, we tell you we don't make a fan required. But if a fan is implemented, then the fan has to report, then the fan is required to report, these properties. And I'll show you an example of that. So it's a way to say, if you have a fan, it has to be managed, it has to provide the speed and failure signals, and et cetera, et cetera. But if you don't have a fan, that's fine. So there are some things that we can't, this is, the profile is not intended to actually sniff out the hardware and say, hey, does this thing have, you have 5 fans and 3 CPUs and, 8 memory sticks. It's not intended to do a hardware inventory and validate that. It's really saying, hey, whatever your hardware is, have you made that hardware manageable? And then, and for those subsystems that you do have, make sure that you met the requirements for that subsystem. Yeah.
How different you're from IPMI?
How do I differ from IPMI? So the Redfish profile only operates on the Redfish protocol. So you have to, in order to meet the profile, you have to make all that data available via the Redfish API. And so now behind the scenes, behind the BMC, as Hemel showed, Redfish is the public or the user-facing interface external to the box. Internal to your product, you may have lots of IPMI stuff going on to talk to power supplies or other subsystems, but all that gets translated and put into the REST interface for publishing. So you will see a lot of the same kinds of data, but it's obviously not in the same form. So as far as Redfish is concerned, once you hit the box, everything else behind that is up to the implementer. You do it however you got it, but at the end of the wire, you got to send it out via the Redfish API. All right, let me get into the profile document. I'm not going to go through this kind of quick. It's number one, it's not horribly detailed and interesting, but also it's the stuff's available in the spec. We have samples in that bundle as well, and then John's going to get into the content here with the actual OCP profiles. So, like I said, we try to make the JSON document, try to make it as human readable as possible, and also try to make some assumptions of what the defaults should be, so that if you're just trying to make that simple checklist, like I want this required, this required, this required, it's one line it's one line of text per property. So trying not to make this giant structure where everything has to be there. Try to say, hey, if I don't find these, I'm going to make assumptions that I've made reasonable defaults with. The format itself does allow you to build on other profiles. So if you really are doing a layered approach, which OCP is doing, of saying I want base manageability layers, and I'm going to build individual devices on top of that, then you can do that. So you can kind of do a pound include. There's different sections in the document for specifying protocols, for protocol functionality, the different schemas, and also registries and actions. So kind of all the functionality is part of the Redfish spec can be checklisted out here in the profile. So there's versioning as well. Try not to get too heavy with the versioning. Like I said, we don't want to see people revising their profiles over and over again, because we want these to be good targets for implementers to shoot for. So it's kind of a put a stake in the ground and let it sit. Now, a year or two later, you might say my baseline has changed. That's time for a new version. Maybe you give it a different name. It's one of the things we kind of need to think about. I don't like assigning years to things where we think that, hey, I'm supporting, profile version, version 2010. It's going to sound kind of odd in another 5 years. So we'll need to think about that. Okay, so the JSON document structure, like I said, it breaks it into individual sections for protocol features, and then there is a resource area, and within the resource area, there are then blocks for for each of the schemas that are part of your profile. If you don't need a schema, you don't have to mention it. So this is, again, trying to make the document as small as possible. So there's nothing in here. Basically, if it doesn't appear in the document, there are no requirements. So you don't have to spend a lot of time filling out lots of blank forms. You know, if it's not mentioned here, you don't have to have it. And then the last part is you know, if there's a need for the message registries, basically do the same thing there. You know, whichever registries you need, and whatever messages are required within there. And I'll show you examples of all that. So you know, within each of the resource, the blue area here, that's where the bulk of the work goes, because it's really mostly the data model and the schemas that are putting in the requirements, and so then that's where they will get defined. So I'm going to go blast through these kind of things, because basically this is just JSON. So if you've seen Redfish already and you've seen JSON, you kind of know what this all looks like. So you know, very straightforward. Try to get as much of this in plain text as possible. So basically start with the basics. You know, what information is needed to just identify this document, know who to contact if you have questions. And then, you know, like I said, there is an ability to require another profile. So this is basically a pound include. So if you're just building on another profile and making some extensions to it, you can do that without having to repeat everything. And then lastly on that slide is the individual requirements for the Redfish protocol. There aren't very many of these because the protocol is pretty straightforward. But you can make, you know, some minimum version requirements, and then things like there are some query parameters, the discovery protocol. You can mark those things as you know, as required as well. So down at within the schema level, we get into the individual schema files and then their properties. So the format is that it's just the schema name. So here I've got a made up one called the Contoso Time Machine schema. You know, and basically you specify where that schema comes from. So this allows the tools to go find the schemas and then, you know, ingest them to do the comparisons. You know, you can, again, minimum feature. Minimum version requirements if they're necessary, and then you get into the individual properties. So, like I said, the individual property, if it's just a simple check mark, so here, current time, that's a required property. So there's nothing else needed to mention there. So just put the property name, it's an empty object, and you're done. But you know, there are some things we want to make that aren't necessarily required, but we want to say that they're recommended, and that's a way to say, hey, you know, it would be nice if you had this, or maybe you don't have to have it this year, but next year I'm going to make it required. So I'm kind of giving you, you know, ample notice here that these are things that are going to be, you know, more important in the future. So you can do that. So that read requirement is where that comes from. And then the paradox detected, that if implemented, this is how you do a fan. For instance, so if that paradox detected, that may be a piece of hardware, and so I say if it's implemented, you know, then it's a requirement. And what we would see then is, and I'll show you, I think I've got it on their slide. You know, the object underneath that would have requirements on it, so they would be applied to that object if the object was present. So I'm running short of time now, so I'm gonna keep going. So the functionality is, like I said, that kind of covers the basics of this. There are some, we try not to go too crazy with conditional requirements and lots of other things. There are some times where you do want to make some conditional requirements because, for example, some of the schemas get to be reused, like Ethernet interface can show up as a NIC for a computer, but it can also be a NIC for the BMC, and those things can have different requirements. So we allowed you to do some things to say, you know what, if this is a specific type of NIC, you know, then these are the requirements, you know, and if it's not, then they don't apply. And you know, a lot of times you'll see the sort of recommended versus required. It will depend on, you know, what kind of machine this is or specific types of products. The other thing is, like I said, for things like NICs that can show up in several places in the model, where it shows up in the model may be the key difference. So, you know, we have the ability to specify the relationships to the parent resource. So, and I'll show this on another slide. Here we go. Yeah, there it is. So this, what it says, subordinate to resource. This is basically saying, hey, if you've got a NIC that's part of the manager subsystem, so it's linked from the manager resource, then it would be required. But if it's on the system side, you know, linked part of the computer systems, you know, really the server NIC, then the requirements may not be, you know, as rigid. The example here is that, gosh, if I need to be able to fully configure the IP stack for the BMC NIC. I need to be able to set the DHCP settings and anything else that's in there. But from the BMC, I may not be able to access that information or may not be able to control the IP stack for the host NICs. May not even want to do that. But so I want to say that those are recommended functions, or they may just be have no requirements on the system NICs. But my gosh, I ought to be able to configure everything about the BMC's NIC. So that's the difference there. A lot of these examples kind of work better when you look at them as a whole, and in the sample document that we have, and actually now with the profiles that John's going to show us here that are real world examples that get to be actually cohesive and kind of make sense. So one of the most important things that I don't show on this slide is that each of the requirements has an optional property called purpose. And so you can kind of write yourself a note as to the why is this requirement here, and it would be just those kind of things, must be able to configure the BMC's IP stack, optional support for configuring the host NICs, as an example. All right. So like I said, there's some more of this. I'm out of time on this, and I said I didn't want to bore you to tears with the gory details of the JSON document. So I'm going to skip through the rest of this. But needless to say, it's in the specification. It's in the samples, and like I said, you can get into the actions, the parameters that have to be supported. It's all in there, and trying not to be horribly detailed. So with that, let me stop for questions. And if not, we'll let John get into an actual use of this.
All right, thanks, John.
Hey, thank you.